Good morning, students. This is a Vipin Prohit. Now we will discuss solubility. This is second lecture of the session. Now we will discuss about solubility. So solubility may be defined as the capability of solvent to dissolve solute in per 100 ml. Means we will check at the ratio of per 100 ml the capacity of solvent to dissolve solute. Now solubility of a gas in a liquid. We have already discussed the solution formed by 9 type. Solid plus solid is equal to also form a solid solution, solid plus liquid, etc. and etc. So solubility of a gas in a liquid can be explained by Henry law. Means how you can say solubility of a gas in a liquid. Solubility of a gas in a liquid is same that as oxygen dissolve in water, or just you can say as CO2 dissolve in cold drink or soda lime. Okay, so what is Henry law? According to Henry law, partial pressure of a gas is directly proportional to the mole fraction of gas in a solution. Means partial pressure means total pressure, the total pressure composed by the each component of the solution. This is partial pressure. Suppose we have, this is a solute A, this is a solvent B, and formation of a product solution P. So the total pressure of solution is composed by A and B. So the pressure of A is also known as a PA, the pressure of B is also known as a PB, and the mole fraction of A is also known as a XA. The mole fraction of B is also known as a XB, and the total mole fraction is X, which is composed by XA plus XB. This is total mole fraction. Now according to this law, PA is directly proportional to XA, where PA is equal to partial pressure of A component, which is gas, and here proportionally, by removing proportionally constant, PA is equal to KH into XA, where KH is equal to Henry constant. The value of Henry constant for different liquid is different. Means the value of Henry constant for water is different, the value of alcohol for Henry constant is different, the value of Henry constant for acetone is different. Means other solvent contain different value of Henry constant depending which is the solvent we are going to use. So dear students, solubility of a gas in a liquid can be explained by Henry law, but solubility of a liquid in a liquid, solubility of a liquid in a liquid can't be explained by Henry law. For explanation of solubility of liquid in a liquid can be explained by Raoult's law. But before proceeding Raoult's law, we have need to explain some terms. Means volatile and non-volatile solution. Then what is volatile solution? Volatile solution are those solution in which both component are in vapor phase. Means both component can be changed or can be converted into vapor phase. For example, alcohol and acetone. For example, alcohol and water. Because both phases, solute plus solvent, are able to convert into vapor phase. This is volatile solution. Now come to the point, non-volatile solution. Non-volatile solution are those solution in which only one component can be converted into vapor phase. For example, n-hexane plus phenol, n-hexane plus alcohol. This is the example of non-volatile solution. Now we are going to explain some. Now we will discuss the Raoult's law for volatile solution. Here it is important for you, Raoult's law is not only a single law, it is the combination of two laws, volatile and non-volatile solution. Here Raoult's law for volatile solution. So according to this law, partial pressure of solute is directly proportional to its mole fraction. Or just you can say partial pressure of solvent is directly proportional to its mole fraction. Means both component, this partial pressure is directly proportional to its mole fraction, the partial pressure of solvent is directly proportional to its mole fraction. So the partial pressure of solution is directly proportional to its mole fraction. Why? Because this is the volatile's law. Volatile solution, and for volatile solution all the components can be converted into vapors phase. Here Pa is directly proportional to Xa, where Pa is partial pressure of a component. Pressure of a component is partial pressure, and the Xa is the mole fraction of a component. So this is Xa and this is Pa. By removing proportionally constant, Pa is equal to P naught A Xa, where P naught A is the pure phase of vapor pressure. This P naught A is pure phase of vapor pressure. Remember, this Pa is the partial pressure and this Xa is the mole fraction. Here same as Pb is directly proportional to Xb. While by removing proportionally constant, same as well as this one, Pb equals to P naught B Xb. And I also discussed P naught A and P naught B are vapor pressure of pure phase. So now we can calculate the total pressure. The total pressure is equals to PS. PS means pressure of solutions is equal to Pa plus Pb, means the total pressure of solution is depend of A component plus B component. So Pa is equal to P naught A Xa and Pb is equal to P naught B Xb. By putting the value of Pa and P naught Pb is here. So P naught A Xa and P naught B Xb. But we know that the total mole fraction of a solution. But we also know the total mole fraction of solution is 1. So we can convert the value Xa is equal to 1 minus Xb. How? By transporting the value of Xa in the right hand side. So side will be changed by the Xa. Now put the value of Xa is equal to 1 minus Xb in equation number 1. So where is equation number 1? This is the equation number 1. Okay. So by putting the value PS is equal to P naught A 1 minus XB. Why? Because of P naught A XA. XA equals to 1 minus XB. This value comes from this one. So by putting the value in place of XA, so came to P naught A 1 minus XB plus P naught B XB. Here the P naught A minus P naught A XB plus P naught B XB. How? By multiplying P naught A into the bracket. So 1 multiplied by P naught A is equal to P naught A minus P naught A XB. P naught A XB. Okay, P naught A P naught A plus P naught B XB minus P naught A. We are changing the same terms plus sign. Same side, negative side are different side. So by taking the common of XB here and XB here, so this XB will be common in both the phase. So P naught A plus P naught B minus P naught A multiplying by XB. This is the law of Raoult's for volatile solution. Now we will discuss about Raoult's law for non-volatile solution. So here one phase will be non-volatile, means can't convert into vapor phase. For example, an hexane plus alcohol. Here an hexane is a non-volatile. This law is also known as a RLVP. RLVP means relative lowering of vapor pressure. According to this law, the total pressure of solution is directly proportional to the mole fraction of solvents. The total pressure of solution means P is directly proportional to mole fraction. So the total pressure of solution is directly proportional to its mole fraction. PS is directly proportional to XB. Here XB is the mole fraction of solvent, while PS is equal to total pressure of solution. So PS is equal to P naught B XB. By removing the proportionally constant here P naught B, and P naught B is the pure phase of vapor pressure of the solvent. So we also know the total mole fraction of a solution Xa plus Xb equals to 1. Now by transporting the value of Xa into right hand side, so Xb equals to 1 minus Xa. This Xa will be turned on this side, then sign will be changed, then Xb is equal to 1 minus Xa. Here by putting the value of xb into ps is directly proportional to xb. So p naught b 1 minus xa. Why? Because xb is equal to 1 minus xa. So by putting the value here, so p naught, by multiplying the p naught b into bracket, p naught b minus p naught b xa, ps is equal to p naught b minus p naught b xa. By the transportation of ps and p naught, by interchanging this ps and this one into left to right, right to left, so sign will be changed. This will be come to this side and this ps is come to this side. So this is positive, this will be come into negative, and this negative will come to positive. So p naught b xa is equal to p naught b minus ps. Okay, so what is value of xa? Xa is equal to p naught b minus ps divided by p naught b. Clear? But this xa is the mole fraction, this p naught v is pure phase of vapor pressure in of solvent, this ps is solution total pressure of solution, and this p naught b same as this p naught b. Now we know that the mole fraction xa equals to na plus nb, where na and nb are number of moles of a and b. This na number of moles of a, number of moles of b. So by putting the value of xa in the equation, so x p naught b minus ps is equal to p naught b is equal to na divided by na plus nb. But for a dilute solution, the value of number of moles of solute is less than number of moles of solvent. Due to this, Na can be neglected. So P naught B minus Ps divided by P naught B equals to Na divided by Nb. For the above discussion, we can represent the graphical representation into next lecture. Please share, subscribe, and like this channel. Thank you. Have a good day.